In this demonstration, we're going to talk about how to configure BIOS or UEFI configuration settings. You do this by accessing the appropriate firmware configuration utility for your system. The way you access this utility depends on the system that you're working with. Usually, it's a single key that you press as the system boots before the operating system loads. Consult your system's documentation to learn exactly which key it is. On the system we're working with here, note that it already tried to boot, but it couldn't find an operating system. That's because it has nothing but blank hard drives. There's no operating systems installed, so no bootable devices were found. As a result, it displayed several messages that I can use to find the appropriate keystroke to access my firmware configuration utility. Notice that the second option lets me know that I can use the F2 or delete key to enter the firmware setup. I'm going to reboot the system, and during the boot process, I'm going to press the F2 key. Notice that when I do, instead of trying to boot the system, my firmware configuration utility interface is displayed instead. Keep in mind that the interface displayed here may be significantly different from what you see on your system. In this particular user interface, you'll notice that the screen is divided into two areas. We have a settings structure tree on the left that we can use to select a particular setting area. On the right, we have information associated with each section. On the left, Settings, General, System Information is selected by default. On the right, the system hardware information is displayed. This is a very valuable screen. You can learn a lot about the hardware on your computer by reviewing the information here. For example, we can see that it has 4096 megabytes or 4 gigabytes of RAM installed. We can see the speed of the memory modules, and we can see the memory channel mode. Here, the memory is operating in single channel mode. If I wanted to improve system performance, I could enable either dual channel or triple channel mode. If you see single channel listed as the memory channel mode, it means that your memory is running as slow as it possibly can. The memory technology is also displayed. This tells you which memory slots are populated. Notice that we have 4096 megabytes memory module in slot DIMM A size, and the remaining slots are empty. To enable either dual or triple channel mode on this system, I'd populate the appropriate slots with additional modules. Under Processor Information, we can view more information about the processor. It's an Intel Core i7 CPU. That's a pretty fast one. It has 2 cores. It tells you what the clock speed is, and it gives you the size of the processor cache. Further down, we can see the various hard disk drives that have been installed. You see that we currently have 3. The first one is 500 gigabytes, and the other 2 are 250 gigabytes. We can also see the video and audio controllers. This type of hardware information screen is standard on most BIOS and UEFI configuration interfaces. Another thing you can do here is set the date and time. Remember that your motherboard has a little clock and it's powered by a battery. This clock keeps the time while the system is turned off. Understand that the clock isn't perfect. Time will drift. If it drifts too much, you may need to come in here and reset it. Another thing we can do in the firmware configuration interface is enable or disable the various onboard devices. Let's go over here to System Configuration. Notice that under System Configuration, I have options for my integrated NIC, my parallel port, and my serial port. I can configure how my SATA interface on the motherboard is going to operate. I can enable audio. I can configure my USB, and so on. For example, if we come over here to integrated NIC, you see that it's turned on by default. I can plug a network cable into the built-in port on the motherboard and have it participate on my wired network. In addition, we can come down here and enable the parallel port that's built into the motherboard. By default, it's turned off on this system. If I wanted to turn it on, I could select one of the appropriate modes here. It tells me in the information box what those different modes are. This brings up a very important point, and that's that most good motherboard manufacturers provide a little bit of help within the BIOS or UEFI configuration interface. Where that help is located depends on the system. On this system, it's beneath the settings. On older systems, you'll see it displayed on the right. If you don't know what a particular setting does, just consult the built-in help. It'll save you a lot of time. In this case, if I wanted my parallel port to be enabled, and I wanted it to run in ECP mode, I'd select the ECP option and click Apply. We can do the same thing with our serial port. Currently, the serial port on the back of the motherboard is disabled. If I wanted to turn it on, I'd mark the appropriate option, either COM1, COM2, COM3, or COM4. In the Help section, it tells me the I/O port and the IRQ that the port will use as a result of the selection I made. Another cool thing is smart reporting. SMART stands for Self-Monitoring Analysis and Reporting Technology. It's used to monitor the overall health of your storage devices because hard disk drives and mechanical devices wear out over time. SMART keeps track of the areas that have worn out and reserves others. When you run out of reserve areas, you'll start getting SMART errors, but you must have SMART reporting enabled for that to happen. Receiving these warnings gives you the opportunity to get your data moved over to a new hard disk drive before it fails completely. Let's come down to USB configuration. Here we can decide how we want the USB ports on the back of the motherboard to operate. For example, we may want that USB port to operate in USB 3.0 mode, so we can get the best speed possible. In this case, we want to make sure that we select Enable USB 3.0 controller. If you want to be able to boot the system from a USB port, which is great from a hardware technician standpoint, we'd select Enable Boot Support. From a security standpoint, though, this isn't that great of an option. It potentially allows an attacker or malicious insider to insert a USB drive with an operating system on it and boot the system from that drive. The attacker could potentially access the data on the system hard disk drive, going around the various authentication and security mechanisms you've implemented. For security reasons, you probably want to turn this off. In fact, a lot of system administrators who are really security conscious turn the USB port off completely by deselecting Enable External USB Port. You can also turn your soundboard on. This motherboard has a built-in sound interface. If you want to use it, you click Audio under Settings and then select Enable Audio. If you want to use a different audio interface, maybe you have a really nice audio card and expansion slot, I'd suggest deselecting the Enable Audio option. That way, the system will use the audio interface on the expansion board instead of the built-in one. Let's go to Secure Boot next. Secure Boot is a very important feature of newer systems that uses the UEFI firmware instead of the older BIOS firmware. Secure Boot prevents the firmware from loading an operating system off the hard disk drive unless it has the appropriate security certificate for that operating system. Secure Boot is designed to prevent malicious attacks. It prevents attacks done with rootkits or with the attacker booting the system off an optical or USB drive. We talked about the second type of attacker earlier. It's where an attacker boots your system using a different operating system to bypass your security mechanism. By default, this option is usually turned on, which is good if you're running Windows. But if you want to install some other operating system, this can cause problems. For example, some Linux distributions aren't UEFI compliant. If you try to install one of those distributions, your UEFI firmware won't have a security certificate for the operating system, so the system won't boot. In that situation, you need to turn Secure Boot off. Technically, turning it off does make the system less secure, but it is necessary for some things. Let's go to Performance next. Under Performance, there are several different processor-specific performance options we can configure. Again, the performance options you'll see will vary depending on manufacturer and model. As we saw earlier, this system has a Core i7 processor installed with 2 cores. If we go to multi-core support, you see that we can turn multi-core support on or off. Right now it's running with multi-core support turned on, and both cores in the CPU are being used. Most likely that's what you want. If you wanted your processor to be slower for some reason, you could turn this option off, I guess. In that case, only one core within the CPU would be used. I can't think of a good reason to do that, but you could if you wanted to. We can also configure hyperthread control. Hyperthreading allows each core within the CPU to run 2 processes concurrently instead of just one. By default, it's turned on. So even though we have only 2 cores in this CPU, by having hyperthreading turned on, we can run 4 processes concurrently at the same time. Again, if for some reason you wanted to, you could turn it off. Next, let's go to Post Behavior. Under Post Behavior, we can configure how the system behaves when it boots up. One of the features that you may want to look at is Extend BIOS Post Time. By default, it's set to 0 seconds. That means that there's no delay as the system boots. No delay really doesn't give you time to press the keystroke to access the configuration interface that we're in right now. For most users, that may be a good thing. You don't want that message displayed for very long. But there may be situations when you need that message displayed for a longer period of time so that you have time to press the appropriate key. In that case, you could change it from 0 to 5 seconds or even 10. If you do, be aware that it does slow down the boot process because the system is going to sit there for 5 or 10 seconds before it finishes booting up. The last thing we want to look at is virtualization support. Virtualization support enables you to run virtual machines. This can be useful if you're developing apps, developing training, and so on. It allows you to run multiple instances of different operating systems all at the same time, all on the same CPU. For this work, you have to turn virtualization on in here. Some CPUs will have it turned on by default and others won't. This one didn't have it turned on. If I want to turn it on, I select Enable Intel Virtualization Technology and click Apply. We've made a few changes as we've gone through the configuration interface, so for these to be applied, we have to do two things. First, we need to save the changes, and then we need to reboot the system. Once again, the way you save the changes will vary depending on the make and model of your system. With some firmware configuration interfaces, you need to press a particular keystroke, like F10. On this system, all I need to do is click Exit and the changes are saved. That's it for this demonstration. In this demo, we talked about accessing our BIOS or UEFI configuration utility and changing some of the settings found there.